Hello, this is Pre-Calc Lesson 38. We have fundamental counting principles, permutations, designated roots, and overall average rate. So let's talk about a permutation. A permutation is the arrangement of the members of a set in a definite order without repetition. Okay, so you're given a particular set and you are to arrange things over and over. Like this. Let's look at the letters A, B, and C. We want to look at how many different ways can we arrange A, B, and C. We can actually arrange them 6 ways, right? A, B, C, ACB, BAC, BCA, CAB, and CBA. 6 different ways we can arrange the orders of this set, right? And we don't repeat, meaning A is used once in this set, ABC, B is used once, C is used once in each of these little ways, okay? Now, this leads us to what is called the fundamental counting principle. The fundamental counting principle is if one choice can be made in A ways and another choice can be made in B ways, the number of possible choices is A times B. Okay, now that seems like a big, vague statement, but I will show you exactly how we will use that. So pause if you need to. I'm going to go ahead. Now, if we have repetition of something, the number of arrangements is always greater, right? So if you can repeat the same letter over and over and over, you have a lot of different ways. So let's do this example. How many ways can the numbers 3, 5, 7, and 8 be arranged if no repetition is permitted? All right, so we have 1, 2, 3, we have 4 letters, so we're going to draw 4 boxes. Okay, now I can put each of these letters in a box. Now, no repetition is permitted. So my first box, I have 4 numbers to choose from. I can choose 3, 5, 7, or 8. Now, if I choose one of the numbers, let's say I chose 3, I only have 3 options left for the second box. I've already used one of my options. No repetition is permitted. Let's say I use 8. Now for my third box, I only have 2 options left, right? 5 and 7, and if I use 5, then I only have 1 option left for my last box, right? I can choose 4, then I can choose 3, then I can choose 2. Okay? Now, this is where the fundamental counting theorem comes into play, I guess. I take each of these numbers and I multiply them, 4 times 3 times 2 times 1, which gives me a total of 24 ways that I can arrange these numbers. All right, let's do another example. How many 4-letter signs, so 4-letter signs, meaning I'm going to again have 4 boxes. How many 4-letter signs can be made from the letters E, Q, U, A, L if repetition is permitted? So I have 1, 2, 3, 4, 5. I have 5 letters. So my first box, I have 5 letters I can choose from. I can choose E, Q, U, A, or L. Now, for my second box, repetition is permitted. I again have 5 choices, right? Because even if I picked E, I could pick E, 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 E. Okay? And again, for my last 2 boxes, I still have 5 options. E, 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 E. Okay? So I multiply all these together, giving me 5 to the 4th, which is 625 ways. All right, let's do another example. And that should say a bad grammar. A multiple choice test has 8 questions, and there are 4 choices per question. How many different ways? So we have 8 questions. Okay, so I have 8 boxes, and there are 4 choices. How many different sets of answers are possible? Now, in this case, let's say my choices are A, B, C, or D. I can choose any of those for the first question. Actually, I can choose any of those for all of the questions, right? It doesn't matter if repetition is happening because I could have all of the answers be A. So this becomes 4 to the 8, which is 65,536 ways. So think about multiple choice tests, grading them. If you have more than 8 questions, there's more than 65,000 ways that you can answer, right? Possible different answers for a test. It's crazy. All right, so that was some permutation. Let's do this example. How many 4-letter signs? So I draw my boxes. Yes, I want you to draw the boxes. How many 4-letter signs can be made from the letters numeral? So I have 1, 2, 3, 4, 5, 6, 7. I have 7 letters, and no repetition is permitted. So that means here I have 7. I've already used 1. So my next box I have 6 options. My next box I have 5 options. And my next box I have 4 options. I multiply all these together, 7 times 6 times 5 times 4, and this gives me 840 ways, or I'm sorry, 840 signs. Okay. Now let's look at our zero-factor theorem. Our zero-factor theorem says that if the product of 2 or more quantities is 0, then 1 or more of the quantities must equal 0. Right? This is factoring. So with designated roots, we can actually write quadratic equations like this. So it says write the quadratic equation with the roots -3/5 and 1/2. So what that means is if I plugged in -3/5 or 1/2 into my equation, I would get 0. So I'm going to write a factored version like this. Right? If I plugged in -3/5, that means I need to have +3/5 here and -1/2 here. This is the factored version of my quadratic, right? If I plugged in -3/5 here, I would get 0, making my whole quadratic 0. If I plugged in 1/2 here, I would get 0, making my whole quadratic 0. Now I have to FOIL out this equation to get my final answer. So I will have x squared plus 3/5x minus 1/2x minus 3/10 equals 0. And if I simplify this, I get x squared plus 1/10x minus 3/10 equals 0. That is my answer. Okay, let's do another. Write quadratic equation with roots 1 plus the square root of 2 and 1 minus the square root of 2. So I will have x minus 1 plus the square root of 2 times x minus 1 minus the square root of 2 equals 0. Now I have to distribute my negatives inside my parentheses. So I will have x minus 1 minus root 2 times x minus 1 plus root 2 equals 0. And then I have to multiply all of this out. So I will get x squared minus x plus root 2x minus x plus 1 minus root 2 minus root 2x plus root 2 and minus 2 equals 0. Now, here if you look, my plus root 2x, my minus root 2x cancel. My plus root 2 minus root 2 cancel, leaving me with x squared minus 2x minus 1 equals 0. That is my quadratic. Okay, almost done. We're going to talk about overall average rate. Okay, so overall average rate, we know that when an object travels a distance d at a constant rate r for a period of time t, we have the equation distance equals rate times time, and we can rewrite it and say rate is distance over time, time is distance over rate. Now, overall average rate is the overall distance over the overall time. So let's look at this example. Frank and Judy drive for 100 miles at 50 miles per hour. Then they drove, so this should be drove, 180 miles at 60 miles per hour. What is the overall average rate for the whole trip? So overall average rate, I need my overall distance over my overall time. My overall distance, I have 100 miles for the first leg plus 180 miles for the second leg. And now I need to figure out my overall time. Okay? So my time for the first leg, let's call it time 1, time is distance over rate, so we have 100 miles over 50 miles per hour, which gives me 2 hours. The time of the second leg is 180 miles over 60 miles per hour, which gives me 3 hours. So my total time, I add these together, is 5 hours. So my overall average rate is 280 over 5 hours, which gives me 56, and I don't forget units, miles per hour. Now let's continue this example. If Frank and Judy continued their trip, so that means that the first distance was 100 miles, the first rate was 50 miles per hour, the second distance was 180 miles, and the second rate was 60 miles per hour. Okay, they continue their rate. How fast must they drive for the last 120 miles? So distance 3 is 120 miles. We're looking for rate 3. How fast must they drive for the last 120 miles to have an overall average rate of 60 miles per hour? Okay, now we already figured out the time for my first leg is 2 hours. The time for my second leg is 3 hours. And we don't know the time for my third leg. Okay, so what I'm going to do is I'm going to set up my overall average rate. My overall distance was 100 plus 180 plus 120 over my overall time. And we want this to equal 60 miles per hour. Okay, now I'm going to use this to solve for my overall time. So my overall time is going to be 100 plus 180 plus 120, which is 400 over 60 miles per hour, which gives me 20 over 3 hours. Now, I know that my first leg was 2 hours and my second leg was 3 hours. So my third leg, I'm going to subtract 5, which gives me 5/3 hour. So now the rate of my third leg is the distance of my third leg over the time of my third leg. So 120 divided by 5/3 gives me 72 miles per hour. Okay. All right, we will do lots more practice with overall average rate. We'll actually be doing it for a very long time. So for now, you can focus on your other homework.